Okay, welcome. So it's come to my attention that a lot of people are really interested in outer space, but sometimes the variety of technical terms that get thrown at you can be very confusing. So I was just going to do a quick short series on some basic education and not try to get too in depth into terms in case you're just interested in learning a little bit more about space. So today we're going to be talking about just the different basic classes of stars. So we're going to start out by just giving a little shout out to the gas giants, um, which here in this picture, so you see they have Jupiter and then a brown dwarf, a red dwarf, and our sun. So, um, our gas giants like Jupiter and Saturn, they're not quite stars, but we call them failed stars because they kind of are starting to get that way, right? They have all this gas and it's starting to coalesce, but it's not. Um, it's mostly hydrogen and helium, but it hasn't started fusing. And so you're going to realize that that's what creates a star is when we have nuclear fusion. So then we move on to a brown dwarf. Same thing, just far more massive, 13 to 80 times as massive as Jupiter. Still not creating fusion, but it can briefly fuse deuterium, which is a heavier form of hydrogen. Um, so for a while there was arguments of whether they're really considered stars or not, but the consensus is that they're not quite stars, and they kind of occupy an intermediate category. So then we move on to red dwarfs, which is what we have right here. Um, and actually, the closest star to our solar system, Proxima Centauri, is a red dwarf. They're the smallest and most common star in our universe. They sustain hydrogen fusion in their cores and they burn fuel very, very slowly, making them incredibly long lived, often up to trillions of years. So, at the age of our universe right now, 14, 16 billion years, somewhere around there, we've never seen a red dwarf burn out. Every red dwarf that has been in our universe is still here. Um, so then we start getting to our sun. All right. And then here we get to a larger scale. So next we have our sun. We're a yellow dwarf. Okay, so that's just a medium-sized sun. Um, Stable fusion of hydrogen into helium, which gives us heat and light. Now, our sun doesn't last nearly as long as a red dwarf, and you'll find that as suns get bigger and bigger, the shorter they last. So, our sun and stars the size of our sun have an expected lifespan of around 10 billion years or so. Like I said, think about it when you're driving your car. The more you throttle the gas and the acceleration, the more fuel that you burn. So it's kind of the same thing with a star. The larger it gets, the more gas there is to fuse, and so it's going to fuse it faster and live shorter. Okay? So then we get on to the blue and white supergiants here, which are the true heavyweight, massive, you know, giant stars of our universe. They can have surface temperatures often exceeding 20,000 degrees Celsius. They have an extremely high mass, and so because of that, they burn through their fuel very rapidly, giving them a relatively short lifespan of only a few million years. Makes it very fascinating to me, I believe. Just they're incredibly huge, and visually they're just some of the coolest stars in our universe. Um, and then we have our red giants here, which are just the later stages in the life cycle of stars like our sun. So when they start exhausting their hydrogen fuel, it expands and cools, becoming a red giant. And they can swell up to hundreds of times their original size. So that's why, when our sun expands, we think it'll expand to about where Earth is, maybe Mars, somewhere around there. So just huge. But they're smaller mass wise because, they've shedded a lot of their mass. Um, and then they'll eventually shed that entire outer layer, just leaving behind a dense core called a white dwarf. So, again, we just have the smaller gas giants, which get a little bit bigger. Then they start to become a brown dwarf and they can start fusing some elements. And then you get to a low mass red dwarf star where it actually can start fusing helium. And then you get to our sun. And then you get to these blue white supergiants and then red giants. And that's the basic classifications. You can get a lot more deep into it, but if you're ever wondering what people are talking about, there you go. All right, I hope you learned something and stay smart.